A couple of facts. After Victor and Borislav, we have now our Polish colleague, so Hubert Nowak, who is going to present what C and C++ developers can learn from Rust. This topic somehow actually appeared on the screen in the previous presentations. So Hubert is a flesh and blood resident of Poznań, so the greater Poland, whose passion is the history of his hometown. So probably you will start with Tej, won't you?
No. Of course. Yeah.
Of course. Okay. So
Tej is everything, yes. So
exactly.
Polish.
Exactly. So professional development was inspired by three mathematicians from Poznań who cracked the Enigma code without the help of computers. So Greater Poland will always be the greater. They won all the uprisings that they could. They are so much better than the rest of Poland. I'm joking. Okay, thank you so much. So, ladies and gentlemen, Hubert Nowak, give a warm applause, please.
Maciej, thank you for having me. Have you ever worked with a 50-year-old developer who was very experienced in C, but has problems to learn modern C++? Maybe you are working currently with the people who just starting the adventure with the C++, but actually they lost in the maze of possibilities. Oops. Yeah, and then now everybody will see the password.
No.
No.
This is the time for adverts, actually.
And we're back again. Okay. I hope it will be not worst. All right. So maybe you work with the beginners who actually have the problems also because they lost in the maze of the opportunities with the new standards gave them. Maybe you are the developers with several years of experience who just want to, I don't know more good programming practices or learn some new languages. My name is Hubert Nowak, and today I would like to share with you my observation about how the learning Rust can improve our developer skills in both C and C++. And first, short question, do we have some Rust developers on the audience? Oh, just a little. All right. So I hope you will join the presentation. First of all, we will make some short recap of the history. You know probably that C was designed in 1972 by Dennis Ritchie, and in this year it celebrates the 50th birthday. So it's quite an achievement because this language is still widely used nowadays. But in 1970s, the most popular language was Fortran. And the big advantage of C is that the code already written in the Fortran can be easily translated into C. And the second one is that C has much more simpler compiler. That's why it's possible to implement it on the different machines. However, as you probably know, C don't have the object-oriented programming, which is very popular. And here comes the Björn Strustrup, which in 1980 started working with C with classes, which become in 1985 the C++. You know that we have OOP, also the generic and templates in C++. But the biggest advantage in that time was that the C++ is backward compatibility with C. And the third language, which we'll talk about today, is Rust, which is designed in 2010 and currently being developed by Mozilla Foundation. If I try to find some couple of words how to describe this language, I would say that it's quite similar to C, but with this difference that somebody took a wrapper on C to protect people before from wrong memory management or memory allocation. And what is interesting, your code written in C and C++ can be easily integrated into the Rust via C API. Let me tell you a story. I'm a senior developer. Many times I was participant in the job interviews. And when I saw from many years that people don't like use smart pointers. Many times when I have the technical meeting, I try to take a look on the candidate's repository on the GitHub, take some code review, and talk about this on the meeting. And many times there are very clever engineers. They know the C++, but when they want to allocate the memory, they use the new, delete, or even worse, memory and free. And one guy told me that, Hubert, yeah, because many times I asked why you don't use the shared pointer instead, yeah? And one guy told me that, Hubert, what is your point? There are three ideas are equivalent, yeah? If the compiler compiles my application, that's fine for me, and you shouldn't ask about it, yeah? And I thought that, not really, yeah? And then when I asked about some problems with the applications, which they had, many times they said that applications is very well, but they have memory leaks. And my first thought, surprise, surprise, yeah? And after that, I realized that using smart pointers required a different mindset from the programmers. It requires understand the concept of ownership and lifetime of the data. All right, as assume that you are the C++ developers, so you know that in C++ we have the constructors for resource acquisition and destructors for releasing the data. And this is well-known idea called RAII, so resource acquisition is initialization. And then we have static memory allocation, which in variable size and location is fixed during compile time and stored on the stack. And it's awesome because such stack allocated variables are easily cleaned up at the end of the defining scope. So here on my example, I don't really worry about my object because it will automatically delete it on the end of my function. But, however, sometimes when we are working with polymorphic types, we actually need to use pointers and initialize them on the heap. And then I just need to remember to correctly release my memory. All right, so this is the basics, and let's come back to some example from my real world. I'm working in the big SCADA systems as a software developer. And then we have many different components which talk to each other. And here we have some examples. We have SCADA elements, which are many times devices elements like transformators or etc., which have some smaller child devices, yeah? And we want to read some big or major element and sometimes find some major if it's correct or incorrect, yeah? And here it is. I use external component from my company, read the major element, try to find the minor one, and after that, I use the calculation module, pass these parameters, do some stuff, and here, at the end, comes to the question that I know that calculation model was created by me, so I delete this pointer. But what should I do with this pointer returning from external components or libraries? Should I delete this? Or maybe these components or libraries should take care about this memory? And then we come to the conclusion that actually ownership, it's not really about who owns the data, it's about who is responsible for releasing the resources of the object at its end of the life. Let's take a move for a moment to the Rust. Here we have the three main key rules of ownership in Rust. So each variable in Rust has one owner. This can be only one owner at the time. And when the owner goes out of the scope, the value will be dropped automatically. And here's the example. Here the string object in Rust is dynamically allocated. So here I have in both the face braces the both static and dynamic variable. And what is interesting, both of them will be dropped when I quit from the scope. And if I try to do something in my first context, I will have borrow checker errors that it can't be possible. Yeah? And here, I will try to explain you how the ownership in Rust works. Let's begin with the main function. We have string1, and we have first function, which creates some string, and when it's returned as the last line, it will automatically move the ownership from my function to the main. Here, so now the owner of the string created in the function is my main function. Here I create the second string and try to pass to the function. And here, by default, when you pass the parameter to the function takes ownership of your parameter. So here, when I handle this and finish, my string will be released and is no longer valid in my original context. So when I want to actually take and give back the ownership, it's quite annoying sometimes because I will have to return it again, but in the separate string, because string1 will be no longer valid also in the first context. Okay, but Rust also allows to actually not take the ownership, but to borrow the data. And here it's very similar to C, that I can use the ampersand, so pass the parameter as a reference, and then the function will take the, not ownership, but borrow the data, and the data will be still valid, in my previous context. And now take a look, how can we use this information, this knowledge, to actually improve my original program, which I explain you in the C++. First of all, I have some factory to create and read some SCADA element. And actually this factory, it will be not an owner of this data. Yeah? So I will create the unique pointer and move it out of my context to my business logic. Then I have also the second element, which is in the relation that is a child of my first readed element. Yes, so I want to have this relationship. So the one owner of this minor element will be my first SCADA device, but I also need to use it in some other cases. So if I have, for example, 2 or more owners, I will use the shared pointer here. Yeah, and then I create the calculation module, and I think that actually my predictions don't need this data, but just they can just borrow it for the moment. And the best idea if they don't change them, so if they will be const. So in this case, I will use the const references to just take for a moment this data, but I don't really care about the releasing of this memory anymore. And here, what is the best part, when I try to refactor my code in that way, I don't really need to use delete anymore. And this is a good practice, because if you have delete in the modern C++, then take a look again on your code, because I'm pretty sure that something go wrong and you need to refactor or change your ideas. Tell me, I want to tell you something about the lifetime of the variables. And have you ever seen these life functions on the left? Do we have the C developers? Yeah, with the big experience. I'm working with the legacy code, and many times I see the functions with 100 lines of codes, and the 50 first lines are the declarations of variables. Yeah, and when you want to add a feature or debug something, you need to scroll up and down for the half of the day, yeah, actually, to find what's going on there. And when I try to, make some job in such legacy code, first of all, I'll try to make some refactor that my work will be easy after that. And first time, I try to use some braces to actually make the scope of variables much shorter. Yeah, and you see that here you have couple the variables which are related to each other, and then it's many times you will also need to initialize some of your variables near the context where they are used. And this is another very good practice to initialize this just before you use it, this variable, not on the beginning of the function. And then you have another advantage of this solution, of this principle, because you can use the feature which is available in many modern languages, likely also in C and C++, which calls functions. And when you have the form which you see on the right side, it's really easy to encapsulate this part of code to a different functions. Yeah? And after that, you add the new feature, your code is much cleaner, much readable, and much easy to maintain. And this is the most cause of today's, work with the legacy code, yeah? All right. What I have seen many times in my career is actually how the people work with the strings in the C and C++. But first of all, we know that ownership and lifetime can make our lives easier. But when I thought about the C and most hard things in that language, I think that it's actually dynamic memory management. The second thing is actually the string operation, because they are related to dynamic memory allocations, and that's why C, the point one, it's challenging. I have a lot of experience with the SCADA system when we have such problems that, SCADA systems have many devices, need to communicate with different protocols, so we implemented a lot, also some converters between them. So you actually, many times you see the problem which I described here. You have some text, and you want to cast it to the bytes to send somewhere, and vice versa, from the other devices or the other system, you want to return it to the original text. And here we have 11 letters, of course the null terminator, and then the output will be 12. But then one day boss came to you and said that, all right, so our application is so good that now we are going to the new markets. Please, Hubert, add some new languages to our application. Easy, what can go wrong? And then, for example, we have the clients from Japanese, and here is in Japanese hello world is also 7 characters, but when I actually try to convert it to the bytes, I see the output is 22, and when my code will be related to the number of characters of the caster, 7 characters from the users, I take 7 bytes, send it to the devices, I'm done, If we assume that logic, then we have a lot of bugs. And it's because many times we as a C and C++ developers think that the single character is a single byte. But it was worked when we have the ASCII. But today, when we have the internet and many languages, we're using the UTF-8, which is different. Okay, it's compatible with the ASCII, but UTF-8 can be one character can write on 1 to 4 bytes. So in such case, every character in Japanese use 4 bytes. That's why I have 22. And take a look on this example on the left. We come back to here, and I try to handle the single byte from my UTF-8 string in Japanese. And as you know, I try to read middle byte from the first character. And actually, C++ allows it, and I have some garbage output. It depends on the operating system, but it's single byte, which you don't understand. And what's interesting in Rust, what I really appreciate, that the Rust actually don't allows you to do such thing if you want to. And from my perspective, the low-level developer, well, it's great, yeah? Sometimes I think that, oh, it's the future which will be really useful in the modern C++. But how the Rust came to these ideas or these problems? First of all, in Rust, you have to take or inform the compiler explicitly format of the data which you want to handle. So, first of all, I need to cast my string actually to chars, so the compiler will handle it correctly. Yeah? Because in Rust, the default encoding, it's UTF-8. And here, if I want to send it on the low levels of my application, I can convert it very easy to the bytes, and then I'm also sure that everybody also in the future will know what I'm going to do, yeah, and what I want to handle here. And what is interesting, that actually the modern C++ is going into the similar direction. You see that since C++ 17, we have the UTF-8 literals, as you see in this example. But the problem is that if your operating system is encoded in UTF-8, then fine, everything will work correctly. But if it's not, for example, on the Windows, then we'll still have the garbage bytes on your pointer. That's why, since C++ 20, the same code gives you the compile error. But don't worry, C++ 20 gives you something else also. And this is new type, char8, which guarantee that string or literal which you store, it will be handled as a UTF-8 string. But here I need to add also some star, because unfortunately we still don't have IO streams for this type, so we can't get UTF string into and out of our program. Okay, another question for you. Did you hear the rule use const anywhere possible? Who heard this? Oh yeah, some. And who use it to on each work? Yeah. Ah yeah. All right. Yes. Okay. If you didn't hear about it, it's very good practice, and I will show you. I will recommend you actually the great presentation made by Jason Turner a few years ago here on this conference, when he talked about this rule and actually the benefits which it takes. Yeah, they have very good examples and how const could improve your output and output code. And if you know this rule, you probably appreciate that In Rust, every variable are const by default. And here, when I create the x variable, it's const by default, so actually I cannot assign any other value to it. And in Rust, it's different mindset, that actually you need to add special word, przepraszam, to actually tell compiler that this variable should be mutable, here. And also, when we want to, I can also pass the mutable reference to my function if I want to change them, but with not taking the ownership of this data. And this is a quite nice approach here. All right. If you are interested in Rust and you want to learn something more, take a look on the result objects which are implemented in Rust, because it's a really nice concept, which you can also implement in C++ in your projects, and it made your unit test much cleaner. I use it in my current team, and they really appreciate this idea of using such objects. And the second thing, if we have some C developers, you can take a look on object-oriented programming in Rust, because since C11 standard, we have very similar mechanism of implementation of object-oriented programming. And in Rust, it will be much easier to understand it and then switch again to the C if you want to. All right. Let's make some summary here. I think that I really admit that what the creation of the Rust do. Well, actually, I have dreaming about this in C++ for a couple of years, because it's look like they take all this stuff which we have developed from the 50 or 40 years already in C and C++ and divided it into two sections. First of all, the things that compiler actually, or the language allows you, but which you should avoid. And the other thing, which are really good practices, you should use it, and then they actually bake it into the language, that you don't have to learn it, you don't have to remember about it, because it's by default in the language. And I imagine, the new Rust adept who will learn all this stuff and then switch to the, for example, C or C++, and I hope that this good behaviors, this good practice will stay with him when he will be programming different languages. And here, I should add some, or maybe more, timeline. And one question for you. Did you hear about the CPP front or the CPP tool? Oh, yes, couple of hands. All right, so who don't know, I will tell you that on this year, on the CPPCon, Herb Setter started the experiment who tried to do exactly the same, but with the C++. So he actually divided some things that that compiled the language allows you, but you should avoid, and actually create some wrapper to the C++ to that the programmers will use only the good practices. Some good practice will be baked in the new C++ 2.0. Currently, it's experiment. He knew that it can fail, but he wants to get experience and try to find out if we can change. Can we still use the C++, but with the modern mindset, I think. And what is interesting, I saw some examples of this code, and the syntax and ideas are very similar to the Rust. So it's another thing that you can consider learning Rust, but because when the C++2 one day appear, many mindset will still be with you, and you can use it with your future work very easily. Okay, thank you for your attention. I hope you enjoy the presentation. And if you have any questions, I'm here for you. Thank you very much.
I hope I'm audible. Yeah, I am. All right, ladies and gentlemen, so once again, thank you very much for the presentation. Normally questions come from this room and it's pretty active, so maybe 2 opportunities for someone to raise a hand. I'll just jump in and pass the mic on to you. If anyone, please just let us know. If not, then the next coffee break will be a chance, but let's just see. We have a colleague who would like to ask.
What would you recommend for jumping into Rust for C and C++ developer?
Well, what I recommend to do, just try.
Yes, but any specific sources or just...
Yeah, okay. I have also the biography up here. So if you take a look on them after the code dive, you can take a look on some. Actually, the Rust programming language book is quite well done because they have many examples and it's actually written as a tutorial. So actually you can, they explain in each chapter each different mindset which they create to this language. So it's quite nice because you can just pick some of them which you are interested in and you don't have to read all of them, yeah? And try, practice.
Any other questions about the Rust? So now an opportunity to ask for the very last moment. If not, if there is someone, can we see anyone? I cannot see anyone at the moment. Just having a look. Oh, here's the mic.
Oh, yeah.
Hello.
Audible.
Thanks for your speech.
Yeah.
Do you know and can recommend some tools like borrow checker for C, C++?
Blockchain tools for C?
Borrow checkers, like in Rust implemented, there are. So borrow checkers like you can
yeah,
have
actually the
mutable reference twice or something like that for C, C++. Are there any tools like that?
Oh, okay, so the problem is that in C++ we have lack of the good tools. This is when you see the Rust, when actually it's created as a modern language. So you get the language, you have also all tools which are standardized, everybody use it. You have the cargo, which is the package manager. You have the borrow checker, so you have some kind of static analyze. And so you have, by default, you have language and all necessary tools by default from package, yeah? And in C++, we have very old tools, yeah? For example, yeah, the debugger, the valgrind are all already written in C, and I think that they have in 1980s, 1990s, yeah? So in C++, we don't have many good new tools. We don't have the borrow checker, but we have some static analyzers, yeah? And you need to check if there are some kind of, it's a couple of them on the market. Just try CPP check or something, yeah? What would you like to do, to use?
I think this exhausts our, let's say, available time. So once again, Hubert Nowak, please give a warm applause and big thanks for the presentation.